Welcome to Study Session 12, Investment Criteria in Public and Private Sectors, Part 3. Introduction. This unit describes yet another investment criterion, internal rate of return criterion. This criterion has to do with both the stream of benefits and that of costs. The knowledge of the net present value, NPV, is required to compute this criterion. Internal rate of return criterion. The internal rate of return, IRR, is the rate that discounts the stream of benefits to equality with the stream of costs. It is the break-even rate of discount which makes the PV of expected benefits equal to the capital cost of the project. More so, it is the rate of discount at which the net present value, NPV, is zero. These statements can be represented by two formulas below. The limitation of this approach is the amount of computation involved. In most cases, the trial and error method of computation is used. The IRR approach assures that as long as the internal rate of return, that is R, is greater than the market rate of return, that is I, the project is worthwhile and profitable. Hence, for a project to be viable, IRR must be greater than I. But in the market situation, R is equals to I. Trial and error method of computation. Assuming that the initial investment of a typical project is 1,000 naira, with a lifespan of 5 years, with the following flows of cost and benefits. Note, there is no replacement of any equipment during the lifespan of the project. Our concern is to determine the NPV of the cash flows of the stream of income and the internal rate of return that equates the PV of the cash flows with the initial investment cost. After obtaining the PV, we then compare it with the initial investment cost. If the PV is smaller than the initial investment cost, we then try a higher interest rate and vice versa. We continue the process until we are able to determine the PV of the cash flow that is approximately equal to the cost of initial investment. The interest that brings about the equality is defined as the IRR. However, the NPV equals discounted benefit minus discounted cost. Therefore, the interest rate that makes NPV equals to 0 is the IRR. At the 10% rate of interest, the NPV is shown as follows. This PV is higher than the initial investment. We then try a higher interest rate of 15%. The interest rate is somehow higher than the initial investment outlay, but very close to it. We can try a little interest rate, let's say 16%. This discount is lower than the initial investment. The break-even value of IRR is therefore between 15 and 16. The actual value of IRR can only be interpolated since the discount table does not provide for any value between 15 and 16 discount factor. The IRR equals 0.25%. In another example of a project shown below, the IRR is 100% and 200%. In these two cases, we have two different IRR for each project. The problem then is which of the IRRs do we use to be more appropriate in determining the profitability of the project. In some other projects, the IRR may not be unique at all. That is, there is just an imaginary IRR in that no real IRR exists. Let us consider an example of a project shown below. In the above example, the sum of the undiscounted benefits is greater than the sum of the undiscounted costs. Then there will be a single internal rate of return. 1. Having more than one internal rate of return, IRR, may be due to the fact that the life of the project is more than 1 year. 2. IRR1 depends on the social rate of discount. If the NPV of two alternative projects are given, the choice of the project will depend on discount rate. This is illustrated in the figure below, where the rate of discount is measured on the horizontal axis and the NPV is measured on the vertical axis. The curve AA discount rate is beyond 7. Project B will be chosen. 3. The RRR is also a ratio, just as the BC ratio. The RRR ratio, again, does not show the absolute magnitude of the project. For example, in the above examples, it shows that both projects have the same IRR, whereas the absolute magnitude differs. Assumptions of investment criteria. The net present value NPV, the initial rate of return IRR, may be compared under the following assumptions. 1. The scale of a project is given and does not have to be co-determined with project choice. That is, we are not concerned with the size of the project, but with whether the project is worthwhile or not. 2. The optimum starting time is given. 3. There is no mutually exclusive condition. 4. Funds are not limited. That is, there is no capital rationing. If all these assumptions hold, then the criteria will give identical ranking of projects, and therefore the same decision rule will apply on whether a project should be accepted or rejected. In any case, one can still discriminate between the three criteria by examining the properties of each criteria. This is the end of study session 12. Thank you.